Assalamualaikum warahmatullahi wabarakatuh. My name is Tazkiyatul Untsa from class 11-2 group Gamma rays. I would like to present to you about gamma rays. First, I will explain about definition of gamma rays. Gamma ray, also called gamma radiation, is electronegative wave that come from the excitation and the excitation of electron. Gamma was coming from the word of atom core. Gamma rays are produced primarily by four different nuclear reactions: fusion, fission, alpha decay, and beta decay. Gamma rays denoted by the lowercase Greek letter. Next is spectrum of gamma rays. First, penetrates our atmosphere. Gamma rays cannot penetrate the atmosphere. As you can see, there is symbol N, which means no, and the color around it black. And the radiation type of gamma rays wavelength is 10 to the power minus 12. Next, an approximate scale of wavelength like atomic nuclei. And about frequency of gamma rays is 10 to the power 20 Hz until 10 to the power 25. Next, and the last, temperature of object at which this radiation is most intense wavelength emitted is more than 10 million Kelvin. Next is mechanism of gamma rays. You can see mechanism of gamma rays on this video.
The nucleus of radioactive material emits three different types of radiation rays, called alpha, beta, and gamma. Due to the distinct electrical charge characteristics of the alpha, beta, and gamma rays, they can be separated by directing a beam from a radioactive source through a magnetic field. Alpha rays carry particles originating from the nucleus of a radioactive atom. These particles consist of 2 protons and 2 neutrons. Essentially, they are positively charged helium atoms stripped of their electrons. The magnet causes these particles in the alpha ray to bend in one direction. Beta rays are a stream of negatively charged electrons. After passing through the magnet, they bend in the opposite direction of the alpha ray. Because electrons of the beta ray have less mass than the protons and neutrons in the alpha ray, the beta ray undergoes a more pronounced bend. Gamma rays are pure energy. Because a gamma ray has neither mass nor charge, it remains unaffected by the magnetic field. The unique characteristics of these three types of radiation affect their capacity to penetrate various materials. Whereas an alpha particle is stopped by a sheet of paper, a beta particle easily passes through paper but is stopped by aluminum. A gamma ray is not impeded by the paper nor aluminum, but its progress can be stopped by lead. The degree to which each of these three forms of radiation penetrate human tissue is the basis for limiting a person's exposure to radioactive material. In terms of the impact of radiation on the human body, alpha particles are generally stopped by the outer layer of skin and pose no real harm to underlying tissue. Beta particles, however, are not stopped by the protective layer of skin and can damage deep sensitive tissue. Gamma rays likewise can penetrate deep into the body and cause harm. This is why it is necessary to wear specialized protective gear when working with radioactive materials. When a neutron is fired at high speed into an atom of uranium, it will split the atom in a process called fission. The stability of the nucleus of an atom is maintained by the balance between the repulsive electrical force among protons and the attractive nuclear forces holding the nucleus together. With uranium, this balance is unstable. Thus, when a fast-moving neutron collides with the nucleus of uranium-235, it is stretched into an elongated shape. This elongated shape tips the balance in favor of the repulsive forces, and the uranium-235 atom splits into fragments of krypton and barium. 3 neutrons are also generated from this powerful release of energy. The 3 forcefully ejected neutrons can each strike an atom of uranium, resulting in the case of an atomic bomb, a catastrophic chain reaction. The nuclear fission process is also the source of energy used to operate nuclear power plants. In a controlled environment, the tremendous heat generated by splitting uranium-235 is used to produce steam that drives turbines to generate electricity.
Jadi, dari video tersebut dapat diketahui bahwa sinar gamma berasal dari proses peluruhan zat radioaktif yang terjadi pada inti atom. Zat radioaktif di sini adalah uranium. Setelah nukleus meluruh menjadi inti baru, biasanya ada energi berlebih dalam ikatan intinya yang menjadikan inti tersebut tidak stabil atau sering disebut dalam keadaan tereksitasi. Inti energi berlebih akan melepaskan energi dalam bentuk sinar gamma atau disebut sebagai peluruhan gamma adalah foton. Pada proses peluruhan juga biasanya menyertai peluruhan alfa dan peluruhan beta. Sinar gamma tidak mengalami pembelokan atau akan tetap lurus saat medan magnet diberi sinar gamma tersebut. Next, historical of gamma rays. There are inventor of gamma rays. First, Anthony Henry Becquerel. In the end of 1890, Becquerel discovered radioactivity. Inadvertently, he covered the uranium salt by using thick black paper and put it on the dry plate photo. And then he put it into the drowner without expose it to sunlight first. A few days later, he found that the dry plate photo became dark. He speculated that the radiation is stronger than the X-ray. Next, second, Marie Curie. Quantitative measurements were initiated by Marie Sklodowska-Curie with her husband Peter Curie developed radiation measurements method. The results showed that all the uranium compounds studied were radioactive. Next, third, Paul Villard. Paul Villard, a French chemist and physicist, discovered gamma radiation in 1900 while studying the radiation emanating from radium, polonium, and uranium. He finds that gamma ray can not be deflected by magnetic fields. Next, and the last, Edna Rutherford. In 1903, Edna Rutherford name is the radiation gamma rays. Rutherford had previously discovered two other types of radioactive decay, which he named alpha and beta rays. Next is application of gamma rays. There are many applications of gamma rays. First is gamma camera. Second, gamma rays used in the sterilization process for medical staff. Third, CT scan gamma rays. Fourth, food sterilization using gamma rays. And the last, gamma knife. The gamma knife was created in 1968 by a neurosurgeon, Professor Lars Leksell Sweden. The tool is gamma ray therapy device, radiosurgery, used for the treatment of tumors and other abnormalities in the disorder of the brain without opening the skull bone. Gamma ray radiation is used to destroy sick cells while keeping the other cells that are still healthy. Next, this is video about mechanism of gamma knife.
The gamma knife, also called stereotactic radiosurgery, is a type of radiation treatment used commonly for brain tumors. It may also be used for other abnormal conditions of the head. The gamma knife is a non-invasive surgical procedure that doesn't require incisions, which are cuts through the skin. Instead, a machine precisely focuses and delivers about 200 beams of radiation onto a target area inside the head. The radiation only kills abnormal cells, while sparing the normal tissue around them. The gamma knife treats small brain tumors, blood vessel malformations, and nerve conditions that are hard to reach or too risky to treat in other ways.
The Gamma knife head frame has 4 pins or screws. After numbing the scalp, the doctor will attach the head frame with the screws. The frame prevents the head movement and helps guide the radiation beams. With the head frame in place, an imaging study, such as an MRI or CT scan, will be done to determine the exact size, shape, and location of the target to treat. The treatment team will use the imaging studies and advanced software to create a treatment plan. Then the patient will lie down on the Gamma knife couch. A radiation helmet will be positioned over the head frame. The helmet contains holes that allow only the programmed radiation from the treatment plan to pass through. With the helmet in place, the couch will slide into the radiation unit. The procedure is silent and painless. It takes a few minutes to an hour or more, depending on the size and shape of the treatment area. The effects on the tumor occur over a period of time after the procedure. For more information, talk to your doctor.
I think that's all from me. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.